Hello everybody, welcome back to Ram Sargi class. Today we shall be dealing with the third chapter in syllabus, as we have studied two chapters in which we did study about the electrostatics and its different properties. And today we shall start the motion of charge. That is, charges are in motion, they will produce different sort of properties, like first is current, then the potential is already there. So current will play different sort of games and then will play with you in different modes. So my third chapter is today current electricity as far as the NCERT syllabus is concerned, and very first topic is what current is. So what do you mean by current is? What do you think electric current is? It's simply what? Shock, it's light, it's power? No, it is simply the motion of charged particles, right? In the last or first chapter we studied about electrostatics. In that or in those topics we used to have what? The charges were in motion and they were producing different players like potential, electric field and polarization, capacity, capacitors and their own applications. So today we shall discuss about the electrodynamics. Electrodynamics is simply a small word for our syllabus, but however it is electrodynamics means electro means electric effects when charges are in dynamic motion or they are in motion rather. So first topic is electric current, and electric current is imagine you have a space or you have a conductor of this short. So this is a conductor. Now I shall raise the question, what is a conductor? What is an insulator? What is a semiconductor? Conductors are those bodies in nature which have got inside them what? Free electrons. It means these electrons are not bound with their nucleus well inside the volume of this conductor. However, they will not leave this conductor and then go away, but they will be inside the conductor, but they have got a freedom to move well through the medium. And this very special property is possessed by whom? Only conductors. And in some special conditions, this is contained by whom? Semiconductors. Okay. So that's not part of business right now. So if under certain condition the charged particles start flow in a particular direction under certain effect, we shall discuss on those effects. What are those effects? And consider a small charge is flowing in very small time, then simply this is known as electric current. I for electric current, and that is delta Q over delta T. So delta Q is what? A small charge that is flowing maybe through this particular area. It has an area of say capital A. So how much charge has gone away from this side? That is delta K. If the time was delta T, then this is the electric current, or simply what? This is the, if delta T is very small. You know what this simply indication means? The time interval is very small or short, then electric current is given by limit delta T tending towards 0 and del Q over del T, and this equals to dQ over dt, or in mathematical language we know this is the instantaneous current, or rather this is the time rate of change of electric charge, or I say very small interval of time, this much of charge has been gone away through any particular area, so this area. So this is equal to instantaneous current through this region A in a very short interval of time. So this is the definition of electric current. That is charge flowing through any particular area. Okay, mind it, that is charge flowing through any area in unit time is known as electric current. Okay, so I is equal to, simply, this is the simplest definition as far as the class 10th is concerned. And then we come to this sequence, and that is what, if the time interval is very small, however large or small the area may be, but if that is the current and that is the time, sorry, that is the charge in this much of time, then we get dq over dt, that is first derivative of electric charge with respect to time mathematically. This is what, in other words, we can say time current is what, the first time derivative of electric charge, or that is charge flowing through any area in unit interval of time. Now we shall come across the, what if the flowing bodies, that is charged bodies, are positive and charged bodies are negative. So if the charged bodies are positive ones and they are moving away like this inside any conductor, okay, obviously we have to apply or use some battery, and this battery will repel all these positive charges if they are in the battery, and they will move away, and we have the current passing is given by from plus end to the minus end. Okay, if the charges are negative, if the charges are negative, then we have the charges will be moving opposite to that of the plus to minus direction. Or if I write, this is the direction of electric field, you won't be surprised because you have had gone through. So this is a positive plate, this positive plate is creating a positive zone, and this negative is producing a negative zone, and electric field inside the conductor will be from this positive to negative end. So if the carriers, that is moving bodies, are positive, then the electric current will be from plus to minus direction or along the direction of electric field. Okay, now what next? The next is, what if the charge particles are negative? What happens if the charge particles are negative? Then obviously the reverse of this happens. So in that situation, we have the negative charge particles will be attracted towards the positive direction. Even in that case as well, the current is always taken from plus to minus direction. So this is the direction of current, but what's happening here differently? That is, the motion of the bodies, that is charge carriers, are opposite to that of the electric field, or you can say the direction of current will be opposite to the flow of the negatively charged particles. So now comes the idea of conventional current. Conventional current is always taken from or is taken in the direction of the flow of positive charged particles, or it is taken from the plus to minus direction. Okay, so that is a conductor. These are positive charges, so they will move like this, as I already made the diagram. So this is what the direction of conventional current. So in conventional current, the current is always from positive to negative direction in the conductor or whatever is the material is. So the charge carriers will move from positive end to the negative end, and this is the, in conductors, the carriers are what? Negatively charged particles called electrons. So in case of the negatively charged particles, what happens? They are attracted towards the positive end, and this is the known as actual current. Okay, in actual current means in case of conductors, the charged particles will flow from the negative end towards the positive end. So little bit of different in case of conventional current and actual current. In conventional current, the direction of charge flow is in the direction of current, but in actual current, the direction of current is opposite to that of the flow of charge carriers. Okay, now come little more to the mathematical idea. Current is given by delta Q over delta T. So if you have to find its SI unit, that is SI unit of current charge is what? Coulomb, and that of time is T. So the unit of current is coulomb per second, or that is SI unit is equal to what? Coulomb per second, or in it has got another name, that is called ampere. So unit of current is ampere or coulomb per second. So 1 ampere is equal to 1 coulomb of charge in 1 second. So what comes mathematically? The current will be 1 ampere in any conductor if 1 coulomb of charge is passing through a certain region in a time of 1 second. Note down. Okay, this is very important. And what will be the dimensional formula for? So electric current is a fundamental quantity, so its dimension is simply written as A. Okay, ampere. So this ampere is placed inside a square bracket, and that becomes the dimensional formula of electric current, or this is m to the power 0, L to the power 0, T to the power 0, and A to the power 1. Remember, this is a fundamental quantity out of the 7 or 9 quantities in physics, as we had studied in the chapter of dimension and errors. So this is simply the basic definitions of electric current quantitatively and qualitatively.